All right, so where I left off, this number 10 is A because we have our regular deposits, so we can see the same amount is getting deposited at intervals. We also had a withdrawal, so it decreased, but then we had those regular intervals back up. So that is represented there. So you guys have 8, 9, and 10 to figure out from C, D, and E. So be careful. The values and whether you're increasing or decreasing. So 2 of these are decreasing, 1 is increasing. All right, the next thing we're looking at is given the pair of graphs on each coordinate grid, create a list of similarities. The 2 graphs share and a list of differences. Consider attributes like continuous, discrete, increasing, decreasing, linear, exponential, restrictions on domain and range, etc. So we're going to take into number 13 together. For similarities, notice they are both increasing. So increasing. They both have a consistent way of changing. So they're going up by the same amount each time. So we could say their slope is what appears to be the same. So consistent way of changing, same domain. So domain, remember, is your possible x values. So how far are we going to the left? How far are we going to the right? Looking at all the possible x values. Now, what's different? Well, notice we've got one that's a filled in line and one that's a collection of dashes. So one is continuous. The solid one would be the continuous one. And one is discontinuous. Another thing that they have different, we've got a y-intercept of -10 versus a y-intercept of 0. So different y-intercept. And, well, think about it. If it has a different y-intercept, it probably has a different x-intercept, and it does. And x. So different x and y intercepts. One's continuous, one is discontinuous. They are both increasing. They are both more of an arithmetic function. So rather than geometric exponential, they have that same consistency. If we connected all these little dashes, we would have a solid line. So it wouldn't be a curve. So keeping that in mind. So for number 12, make sure, look at what's the same, what's different, and explain that out, okay? All right, and the last section is solving equations. So for each equation, find the value of x that makes it true. Hint for 20 and 22, when solving linear equations, you need to get the term containing the variable alone on one side. When solving an exponential equation, you also need to get the term containing the variable alone on one side. All right. So for the first one, we have 10 to the x equals 100,000. So dealing with exponents. If we take 10 to the exponent, whatever exponent we take it to, that's how many zeros it's going to have. So if we count our 100,000, we have 1, 2, 3, 4, 5. So it's x equals 5. For number 15, we have 3x plus 7 equals 5x minus 21. We need to take and move things around. We need the x's all on one side and the constants on the other side. And remember, when we're solving, it's opposite operations. Some of you had a lot of issues with this. So we have a positive 3x. So to get rid of it, we're going to subtract 3x from both sides. So now we have 7 equals 2x minus 21. Now, we need to move this negative 21 over to this side. So we're going to add 21. So we add 21. We get 2x equals 7 plus 21 is 28. Now, last step, we divide. That's the opposite of multiplying. So 28 divided by 2 is 14. So x equals 14. That's what you guys are doing for these. So on the exponent ones, you have to figure out to what power it needs to go to. Your keyword is functions. If you have any questions,